The sun is like a giant ball of burning plasma that provides light and heat to the Earth. But how does it actually work? Well, in this video, we're gonna find out. So, let's begin. At the center of the sun, the temperature is about 15 million degrees Celsius. That's more than 10 times the temperature on the surface of a star like our sun. The sun is not even a solid object. It's made up of superheated plasma. This means that the sun is mostly empty space with a bunch of charged particles floating around in it. These particles are mostly hydrogen and helium, the same stuff that's in the air that we breathe on Earth. But when they get to temperatures of millions of degrees, they become ionized, meaning that they lose some of their electrons and become electrically charged. The sun's core is under huge pressure, about 250 billion times the pressure we experience on Earth. This pressure is what keeps the sun from collapsing in on itself. In fact, it's what allows the sun to exist at all. Without this pressure, the sun would simply collapse in on itself, and all of the planet's energy sources would go out like a candle. But there's another force at play here. Gravity. Gravity is pulling all of the sun's mass towards its center, which makes sense. After all, this is the same force that keeps us on the ground. But as the sun gets bigger, its gravity gets stronger. And at a certain point, this gravity becomes so strong that it overwhelms the pressure and causes the sun to collapse in on itself. When this happens, the sun goes through a series of nuclear reactions that release huge amounts of energy. This energy is what powers the sun and provides light and heat to the Earth. But these nuclear reactions don't happen very quickly. In fact, it takes about 100,000 years for a single proton to make its way from the sun's core to its surface. That S, because the sun's plasma is so dense, that it is incredibly difficult for the particles to move around. But eventually, the proton reaches the surface of the sun and is converted into a neutron. This releases a positron and a neutrino. The positron annihilates with an electron in the sun's atmosphere and produces two gamma rays. These gamma rays escape the sun and travel to Earth, where they redetected by satellites and help scientists learn more about our amazing star. Now that we know how the sun works, we can start to answer some other questions. For example, why does the sun shine different colors? The sun actually doesn't shine different colors. The reason why we see the sun as yellow is because our eyes are more sensitive to yellow light than any other color. If you were to build a special camera that could see infrared light, you would see that the sun actually shines red. This is because the sun's surface is about 2,000 degrees Celsius, which is hot enough to emit red light. But the sun's core is much hotter, so it emits light at all wavelengths, including visible light. That's why, when we look at the sun through a special camera that can see ultraviolet light, we see a completely different image. The sun's core is so hot that it actually glows purple in ultraviolet light. Another question we can answer is, how long will the sun last? The sun is currently about 4.5 billion years old, and it has enough fuel to burn for another 5 billion years. After that, the sun will become a red giant, engulfing the inner planets, including Earth. So, if you're planning on living on Earth for the next 10 trillion years, you might want to start looking for a new planet now. In conclusion, the sun is a giant ball of burning plasma that provides light and heat to the Earth. It works through a series of nuclear reactions that occur in its core. These reactions release energy in the form of gamma rays, which escape the sun and reach the Earth. The sun also emits light at other wavelengths, including infrared and ultraviolet. In infrared light, the sun appears red, and in ultraviolet light, it appears purple. The sun is currently 4.5 billion years old and has enough fuel to last another 5 billion years. After that, it will become a red giant and engulf the inner planets. I hope you enjoyed learning about the sun. If you did, please like this video and subscribe for more science videos. Thanks for watching.